Okay, I finally got this microphone working, so I thought I would just show everybody what I've been up to in the past hour or two. So I wanted to write a very simple application that would demonstrate LeSage gravity as expounded upon by draft science, and I wanted to make as many simplifying assumptions as I could, just so that I can write this program in under an hour or so. So what I decided to do was take a couple of circles. So I decided to do this two-dimensionally, but it applies just as well in three dimensions. So let's just color the other circle a different color to distinguish it. And what I want to do is show how, let's say these represent planetary bodies. I want to show how they're actually attracted to each other on Gary's theory of force bits. So a couple of simplifying things that I'm going to do is I'm not going to actually animate the two circles moving towards each other, just because that would take more time. Instead, what I'm going to do is I'm going to have the velocity represented by a vector, right? And however the computer crunches the numbers will determine which direction this vector points. So it could point in this direction, but if Gary's ideas are accurate, or if they work, then it should point in this direction, right? And we're only going to do this for one circle because obviously if it's happening for one circle and the arrow is pointing this way, then it's obviously going to be happening for the other mass as well. It's just going to be inverted, and so it's going to be an arrow pointing the other way. And the way I'm going to represent force bits in this program is I'm going to have the computer generate about 5 or so bits that come in completely random directions. So we can have a bit coming and hitting the object from this direction, and we can also have another one in this direction. You get the basic idea. So let me color these so that we can see them. And it's just going to keep repeating that process of generating these force bits and coming and hitting the blue object. And it's going to be very important for the application not to generate illegal force bits. An illegal force bit would be one that comes from the universe and hits the blue object, but it ends up passing through the red object. That's illegal, because obviously this force bit coming in this direction would hit the red object first. It wouldn't end up hitting the blue object. That's the whole point here of the shadowing effect and the pressure on the outside that it indirectly creates. So the program also needs to make sure that whenever a line like this gets generated, we don't want those. We want to ignore those. The only ones that end up hitting the blue are the ones that come from around the red. So I'll just go ahead and fire up the application and show you what happens. Actually, I'll show you the code first. It's less than 150 lines of code, and here we have the two circles that are the blue and green circles being created here. The C1v represents the vector that comes out of C1. That represents the velocity, both the direction and the magnitude. We're going to see that change. And here we have a thread that just loops and generates the force bits. I have it doing about five or so force bits per second, just so that it doesn't overwhelm my machine. And we see down here that the velocity vector for the blue circle is going to get updated, and its magnitude is going to be affected by the magnitude of and the direction of the unit vector for every force bit that comes in. So when a force bit comes and hits the blue object, we're just going to assume that they all have the same amount of energy, which I think is what Gary's theory requires. And we're just going to reduce each of these vectors to a unit vector, and then we're going to add that vector to the present velocity vector. This represents force bits getting absorbed. Okay, so I'll just go ahead and run this application, and we'll see what happens. So here again, you see all these black lines flickering. Those are force bits that are coming in and hitting the blue object. Another simplifying assumption I made is that the force bits will hit the object in the center of the mass. They don't actually go through the object and hit it in its center, obviously, but just to ignore the rotational motion that might be created by some of the vector components of the force bits, I just go ahead and assume that they all hit the center of the mass. As we can see, the velocity vector is getting bigger and bigger, and that's because no line passes through the green object. It's not possible for force bits to come from the lower right corner of the screen and pass through here. That's why you see no lines being drawn through that green circle. And the effect that that has is that there are fewer force bits that are able to hit the blue planet coming from this direction. And what that ends up meaning is that, on average, there are more force bits hitting the blue object on this side. And that's why we see the velocity vector growing towards the green object. Now, it's not perfect this time because these are pseudo-random numbers and we're dealing with very small samples here. We're only doing about 5 force bits per second. But this, is already proof enough. We see as it gets longer, it's moving more and more towards the green. I can repeat this just to show you. Again, because we're dealing with small numbers of force bits, it starts off a little chaotic, doesn't really know where it's going, but then you see, not too long after, it starts growing towards the green planet. Again, the direction is important because if it's pointing towards the green, that means it's moving towards the green, and as it grows bigger and bigger, that's because it's absorbing force bits, and the longer this vector gets, it means the faster that it's falling towards the green object. So, I think intuitively it's pretty obvious that this explains gravity, but for anybody who lacks that kind of intuition and really just likes to see something visual and wants the reassurance of a machine crunching the numbers in the background, this is a pretty good illustration, I think. And, Gary, if there's anything any really easy ways I could make this more valuable to you, feel free to let me know, and I can send this to you as an application that you can run on your machine, or I can send you the Java code itself. It's not much. I'm gonna go ahead and get some sleep. Thanks for watching.